In this video, we're going to be looking at the chain rule from A2 differentiation. Now, there's a few derivatives you really need to memorize before we carry on, and I've got a list of them here. Now, the better you memorize these, the easier it is going to be for you. So if you'd like, pause the video for 5 to 10 minutes and really sit down and memorize these derivatives. Okay, so here we've got the chain rule. We've got dy dx is equal to dy du times du dx. And you need to memorize this rule. So we can use this to differentiate y equals sine 4x. Now we know how to differentiate sine x, and if you memorize that table, you'll know the differentiation of sine x is cos x. However, we don't have sine x here, we've got sine 4x. Now some people have already memorized how to differentiate something like this, and they can probably say the answer right away. However, I'm going to show you how to get the result using the chain rule. Okay, so the thing which is making it complicated is the 4x. So instead of writing 4x, we're going to make that into u. So we've got y equals sine u. And of course, we've made u 4x. So we can say u is also 4x. Now we're going to do some differentiation. So let's go ahead and work out dy du. And here it's simply cos u. And we can also get du dx. Okay, so what can we do with these results? Remember, we want to work out dy dx. And if you look back at the chain rule, you can work out dy dx using dy du and du dx and multiplying them. And that's brilliant because we've got dy du and we've got du dx. So let's go ahead and multiply them to get dy dx. So we've got dy dx equals u cos x. Now, we don't want u in our answer. And if you look back, we said u equals 4x. So we can replace that u with 4x. Okay, so filling in that formula, dy dx equals dy du times du dx. So it's cos u times 4, which we can write as 4 cos u. Now you don't want u in your answer, so you can replace u with 4x. And so we've managed to differentiate y equals sine 4x. Now, a lot of you could do that differentiation without actually using the chain rule and showing it like this. You need not to show all of this working out. You can go straight to the answer. The only time you're going to show all your working out, if the question says show using the chain rule, then you want to show this whole process. Otherwise, you can go from y equals sine 4x straight to dy dx equals 4 cos 4x. Okay, so let's try on this question. We've got y equals e to the 2x. Now, we all know how to differentiate e to the x. It differentiates to e to the x. However, we've not got e to the x, so we've got e to the 2x. So we're going to simplify the matter by replacing that 2x with u, and then go on to use that chain rule. And of course, we've let u be 2x. Now let's go ahead and differentiate both of them. Now you simply need to fill in that chain rule formula. Now if you've forgotten what that formula is, I'm just going to write it out again for you. And we've got the needed parts to fill in the formula. So let's just go ahead and fill it in. So it's going to be e to the power u times 2. 2e to the u. Now again, we don't want that u in there, so just replace it with what u is. U is 2x. And it's as simple as that. Let's do another example. Now I'm going to go through this example a little bit faster. So we've got all our needed parts for the formula. Go ahead and just fill it in. Now I didn't write out the formula because I've assumed you memorized the formula. However, in the exam, if it says show using the chain rule, it'll be good to state what the formula is. Okay, so we've got ourselves a trig one. Now, we should know the differentiation of tan x. It's sec squared x. However, we haven't just got x here. We've got a whole expression. We've got 2x minus 3. So it's a little bit more trickier. Now, that tricky bit, which is the 2x minus 3, we're going to let that be u, just to make it look much easier. Okie doke, so we can go ahead and start differentiating it. And just go ahead and fill in the chain rule formula. Okay, so let's do another example. So the differentiation of ln x is 1 over x. Except instead of x, we've got an expression. So we're going to let that be u. And let's go ahead and differentiate that. And we can fill in the chain rule now. And it's as simple as that. Okay, this one's slightly different. Now, we're going to make 2x plus 3 become u. And it's going to make it a little bit easier to solve. And of course, we'll differentiate it now. And we can fill in the chain rule. Now in this question, technically, 2x plus 3 to the power of 8, you could have just expanded it using binomial expansion and then differentiate each one using the AS differentiation method. However, that will take too long. And then simplifying the answer, you're going to have to factorize again. Now using the chain rule, we've managed to do it very simply. Now here we've got y equals sine 7x plus 1. Now you don't want to show all the steps of your chain rule all the time. You want to get to the answer in one step. You only show the whole chain rule if the question says so. So I'm going to show you generally what you do. So here we've got y equals sine 7x plus 1. We can just look at this as y equals sine fx. Yep. So our fx is that function we've got, 2x plus 1. And generally this differentiates to cos fx. However, if you've been practicing your chain rule a lot, you also know f dash x also comes to the front. So the differentiation of something general in the form sine fx goes to cos fx, but it also gets multiplied by f dash x. So looking back at the sine 7x plus 1, we know it goes to cos 7x plus 1. So this should go to cos of that function. Now we also multiply it by the differentiation of that function, that's 7x plus 1. And the differentiation of 7x plus 1 is just 7. And that's how you expect to do it in one step. You don't show all the chain rule steps. Now here I've got a whole list of derivatives in that form, the general form. So just take a moment to understand these and also memorize them. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.